Glaciers are among the most fascinating yet underrated formations on our planet. Though for most of us they seem distant, cold, and almost unreachable, their influence reaches far beyond the remote regions where they dwell. Covering about 10% of the Earth's land surface, they hold the vast majority of the planet's fresh water. In some regions, more than half of all fresh water is locked away in ice and snow. These immense rivers of ice move slowly but relentlessly through valleys and basins, sculpting the land over thousands of years. Their presence reminds us of the immense power of nature, a force that measures time not in hours or days, but in centuries. Glaciers are not static, monolithic blocks of ice. They are complex systems where frozen water, snow, rock, air, and liquid coexist, forming an extraordinary structure. Beneath their surface lies a hidden world of microscopic air bubbles, tiny mineral fragments, and ancient organisms, all preserved in a frozen archive that allows scientists to read the history of the Earth's climate, stretching back hundreds of thousands of years. Each layer of a glacier is like a page in a vast chronicle, recording droughts, floods, temperature shifts, sandstorms, and volcanic ash that shaped the planet through the ages. Their motion, though almost invisible to the naked eye, is powerful and dramatic. Glaciers creep down mountainsides and valleys at speeds ranging from a few centimeters to several meters per day, carving out rocks, forming moraines and glacial lakes. As they melt, they feed rivers and reservoirs that sustain entire ecosystems. The changes within glaciers ripple through the oceans, influence sea levels, and regulate both local and global climates. What might appear as a frozen, motionless landscape is, in reality, a vast, living organism, breathing, transforming, and responding to the world around it. Standing before a glacier, one can't help but feel small in the face of nature's magnitude. Its surface shimmers with every shade of white and blue, from milky snow tones to deep, almost electric blues that reveal the density and age of the ice. While the outer layer may melt in summer, deep within lies ancient snow, compacted and preserved for millennia. Each fragment is both a witness to Earth's history and a living laboratory where scientists study climate change, geological processes, and the dynamics of ice itself. In this journey, we'll follow glaciers from their high mountain origins through the valleys and down to the places where they melt, feeding rivers and lakes. We'll look inside them to uncover stories written hundreds of thousands of years ago, understand their role in regulating the planet's climate and life, and see how dramatically they react to the changes of our modern world. This is the story of ice that is not dead, but alive, pulsing with history, energy, and meaning that stretches far beyond what the eye can see. Glaciers are not only monumental bodies of ice, but also intricate systems that function much like living organisms, reacting to their surroundings and reshaping the world around them. Their anatomy and dynamics resemble a complex mechanism in which every element plays its part. The process begins with snow, which over time compresses and transforms into dense, blue glacial ice. Trapped within it are tiny air bubbles, time capsules containing ancient atmospheres. By studying these bubbles, scientists can reconstruct climates of the past, analyzing greenhouse gases, volcanic dust, and even microorganisms that survived unimaginable conditions. The structure of a glacier is layered. The upper region, called the accumulation zone, is where snowfall exceeds melting. Here, snow collects and compacts, slowly turning into ice. Below lies the ablation zone, where glaciers lose mass through melting sublimation and the calving of icebergs into rivers or seas. Between these zones, a constant exchange of energy takes place. The weight of newly fallen snow exerts pressure, causing the ice to deform and flow downward, like a colossal frozen river sliding toward the ocean. Glaciers form vast ice tongues that can stretch for dozens or even hundreds of kilometers. They move at varying speeds, from a few centimeters to several meters per day, depending on the slope, the ice thickness, and the nature of the bedrock beneath. The rock under a glacier is constantly pressed and abraded, leading to glacial erosion that carves deep valleys, fjords, and moraines. Accumulations of rock and gravel carried and deposited by the glacier's slow advance. These processes take centuries, even millennia, yet the landscapes they create endure for ages. One of the most fascinating aspects of glaciers is their internal motion. Ice is not rigid. It behaves like an extremely viscous fluid. Cracks, crevasses, and fissures appear as stress builds up from movement and temperature changes. Meltwater often seeps into these cracks, acting as a natural lubricant that accelerates the glacier's flow. Beneath the ice, subglacial rivers and tunnels form, transporting water, minerals, and sediment, and influencing how the glacier melts and moves. Glaciers are also living biological archives. Within the ice, microorganisms, bacteria, viruses, algae, and lichens can survive for thousands of years in near hibernation, preserved by the extreme cold. Studying them helps scientists understand evolution, adaptation to harsh environments, and even how life might endure on other planets. The impact of glaciers on climate and ecosystems is immense. They regulate the flow of rivers, storing water in winter and releasing it in summer, providing a vital resource for millions of people and countless species. As glaciers melt, they contribute to rising sea levels while simultaneously creating new habitats, glacial lakes, wetlands, and streams. They also help cool the Earth by reflecting sunlight, maintaining local temperature balance, and slowing global warming. Glaciers, in their silence and majesty, remind us that the story of water is also the story of life. They are ancient sentinels of time, fragile yet powerful, enduring yet constantly changing. As they retreat before our eyes, they leave behind not only traces in the landscape, but a message about our shared future with the planet that shaped us. In this story about glaciers, we seek to reveal their power, subtlety, and their profound role in the history of Earth. They are not merely cold towers of ice, but living systems that remember thousands of years of climate change, carrying water, minerals, and microscopic life through time. Their slow, deliberate motion is a silent testimony to nature's strength. Glaciers teach patience and humility. The gradual advance of their icy tongues, the carving of valleys, and the steady transport of rock and silt remind us that nature works on a scale far beyond human comprehension. Every crack, every glimmer of blue ice holds the story of millennia, a frozen rhythm of Earth's transformation that still unfolds and continues to shape our world. When we picture glaciers, we often imagine majestic blue masses gliding calmly through mountain valleys. Yet their true dynamics are far more dramatic and unpredictable. Among the most spectacular events are iceberg calvings, immense chunks of ice breaking off from glacier tongues and plunging into the ocean. These frozen giants can weigh millions of tons and stretch for kilometers. As they crash into the sea, they send up towering waves and alter local ocean currents. The breaking and drifting of icebergs is a natural process, but the speed at which it happens today is accelerating with the warming climate, a change with far-reaching global consequences. Another dramatic phenomenon is the glacial flood. When glaciers melt, or when natural ice barriers fracture, vast glacial lakes can form. If their icy or moraine dams fail, enormous volumes of water are suddenly released, devastating valleys and infrastructure downstream. Such events can be catastrophic for nearby communities, while at the same time reshaping the landscape, eroding rocks, moving sediments, and carving new riverbeds. Water that had been frozen in time for centuries can suddenly surge to life, reminding us how much energy and force glaciers silently contain. Equally dramatic is the impact of melting glaciers on global sea levels. For decades, scientists have watched the rapid thaw of the Arctic and Antarctic ice sheets, which contributes to rising oceans across the globe. This phenomenon threatens coastlines and islands, alters ocean circulation, and reshapes regional climates, potentially triggering extreme heat waves, hurricanes, and shifts in rainfall. Glaciers act as immense regulators of Earth's balance. When they falter, the planet's entire climate system feels the consequence. What's truly fascinating is that glaciers have their own subtle language of motion. Cracks and fissures caused by stress and friction against the bedrock generate a symphony of sounds, creaks, groans, and the bubbling of meltwater. It is the music of ice, the sound of continuous transformation taking place before our eyes, though often unnoticed. Beneath the surface, Networks of subglacial rivers and tunnels transport ice, minerals, and even microorganisms, revealing the hidden complexity and intelligence of these vast frozen systems. Glaciers are also vital to life in the oceans. As they melt and calve, they release minerals and nutrients that nourish plankton, the foundation of the marine food web. Each iceberg that drifts into the sea is not just a dramatic geological event, it is an ecological pulse, sending waves of life and energy that ripple through the marine ecosystem, from microscopic plankton to massive whales. To observe a glacier is to experience both awe and reverence. From afar, they appear serene and eternal, yet their existence is filled with drama. From calving icebergs and glacial floods to the subtle, invisible shifts beneath the surface that sculpt landscapes and sustain ecosystems, they remind us that nature operates on scales we can scarcely grasp. And glaciers stand as its quiet, powerful guardians. The most dramatic glacier-related events often remain overshadowed by more familiar natural disasters like storms or earthquakes, yet their impact can be equally devastating. One classic example is the glacial lake outburst floods, known as GLOFs. In the 1990s, several such floods in the Himalayas destroyed villages and roads, claiming hundreds of lives. Glacial lakes form when meltwater is trapped behind ice or moraine barriers. When these fragile natural dams collapse, the entire lake can drain within minutes, sweeping away everything in its path. These events reveal a stark truth. Glaciers are not only magnificent and serene, but can also become deadly when their delicate balance is disturbed. History offers other reminders of their power. In the Arctic and Greenland, massive icebergs have broken away, crashing into the sea with such force that they generated destructive waves capable of capsizing ships and damaging coastal installations. Each calving event acts as a natural energy release, displacing immense volumes of water, reshaping shorelines, and altering ecosystems. There are also historical moments when glaciers have transformed the land for centuries. In the 19th century, glacier tongues in the Alps and Andes advanced so far that they crushed settlements and blocked roads, forcing entire communities to relocate. Meltwater-fed rivers shifted their courses, altering agriculture and daily life. Though slow, glaciers are powerful engineers of the landscape. Through erosion and deposition, they carve valleys, form lakes, and create fertile plains that later become home to forests and wildlife. Yet they are also capable of sudden violence. When an ice barrier fractures or a giant block collapses, the results can be catastrophic for ecosystems and people alike. Watching these processes reveals a paradox. Glaciers are both givers and takers, creators of life and agents of destruction, patient sculptors and unpredictable forces. History teaches us humility. It reminds us that human presence near such majestic and dangerous formations demands awareness, respect, and an understanding of the immense natural powers that shape our world. Today, climate change has accelerated the story of glaciers to an unprecedented pace. What once took centuries now unfolds in mere decades. Glaciers that shaped mountain valleys for millennia are retreating at record speed, revealing bare rock and hidden lakes that only recently lay buried under ice. This transformation carries consequences for both people and ecosystems. In high mountain regions like the Himalayas and the Andes, the increased risk of GLOFs, those sudden glacial floods, is a growing threat. Natural ice dams collapse more quickly, unleashing torrents that devastate valleys, wash away homes and infrastructure, and sometimes claim dozens or even hundreds of lives. Melting glaciers also disrupt the rivers that depend on their steady flow. Sudden fluctuations in water levels threaten agriculture, freshwater supplies, and the delicate balance of river ecosystems. At a global scale, the added meltwater contributes to rising sea levels, endangering coastal cities, island nations, and marine habitats. The ecosystems surrounding glaciers are undergoing equally dramatic shifts. Plants and animals adapted to cold, stable conditions are losing their habitats at an alarming rate. Mountain fish, insects, and endemic species face extinction as rivers change course and temperatures rise. New habitats are emerging in their place, but adaptation takes time, decades, even centuries, leaving a critical gap that endangers entire populations. Climate change is also exposing hidden dangers. Dormant glacial lakes, remnants of past ice ages, are becoming unstable water bombs. Geologists and climatologists now monitor these lakes around the world, trying to predict which may burst next and cause catastrophic floods before it's too late. The story of modern glaciers is a story of urgency, a reminder that what once moved, with the patience of ages, is now changing at a pace humanity must struggle to keep up with. Every sudden crack in an ice dam, every massive block collapsing into the sea, every accelerated glacier melt is a message from the planet, a call for respect, preparation, and swift response. More than ever, it has become clear that glaciers are not only majestic sculptors of the landscape, they are also sensitive indicators of Earth's health. Their retreat is not an isolated event, but a signal that the entire planetary system is under strain. The fate of glaciers mirrors our own. The world's largest glaciers hold within them the stories of millions of years. Their scale and motion are breathtaking. The Lambar Glacier in Antarctica, considered the largest on Earth, stretches nearly 400 kilometers long and over 40 kilometers wide at its broadest point, with ice up to 2 kilometers thick. It moves only a few meters per day, yet it transports colossal quantities of ice and water from the continent's interior to the ocean, shaping the land and contributing to the rise of global sea levels. In Greenland and Antarctica, glaciers merge into vast ice sheets that act as enormous freshwater reservoirs. Their melting is one of the most important indicators of climate change. Scientists monitor them using satellites, geodetic surveys, and deep ice core drilling. Within these frozen layers lie hundreds of thousands of years of climate history. Dust, gases, and isotopes that reveal ice ages, droughts, and volcanic eruptions. They form a chronicle of Earth, written in rings of ice that have accumulated slowly, year after year. Some glaciers reveal phenomenal natural wonders that attract researchers and explorers from across the world. Icefalls, formed when a glacier's tongue plunges from a higher elevation to a lower one, create spectacular and perilous formations that resemble frozen waterfalls. Crevasses, deep cracks that can extend tens of meters into the ice, expose the immense tension that builds as glaciers move and deform. Some glaciers even experience periodic ice surges, sudden accelerations in their flow caused by increased meltwater at the base, lubricating their movement. These surges remain partly mysterious, a reminder that even in a field as studied as glaciology, nature still guards its secrets. Glaciers are also vital pillars of the Earth's ecosystems. Meltwater from glacial tongues feeds rivers, lakes, and groundwater, sustaining life in regions that would otherwise be arid and lifeless. In the Himalayas, glacier-fed rivers have supported human civilizations for thousands of years, while in the Andes and Alps, melting glaciers regulate agricultural cycles and secure access to drinking water. Glaciers are not merely majestic blocks of frozen water. They are living arteries of the planet's hydrological system, connecting distant environments and influencing life across continents. Within glaciers lie enigmas of deep time, prehistoric forests entombed in ice, the remains of ancient animals, and microorganisms that have survived for millions of years under crushing pressure, cold, and darkness. In Antarctica and Greenland, scientists have uncovered microscopic life forms preserved in ancient ice, organisms unlike any found elsewhere on Earth. Their discovery opens windows into evolution and the limits of life, revealing how living beings can adapt to extremes that defy imagination. The changes we witness today confront humanity with profound questions. How do we live in a world where glaciers retreat? Seas rise and iceborne floods threaten our valleys, while still depending on these same glaciers for water. Balance and stability? Every cracked tongue of ice, every detached block that drifts into the sea is a reminder that glaciers, though seemingly motionless and eternal, are dynamic, powerful, and exquisitely sensitive to the planet's warming breath. Glaciers, those immense, silent rivers of ice, evoke images of stillness, cold, and desolation. Yet beneath their frozen surfaces thrives an astonishing world of life. sustained in the most hostile conditions on Earth. What seems barren and lifeless from above conceals colonies of microorganisms capable of photosynthesis in near darkness, bacteria that generate energy in freezing temperatures, and algae and protozoa that tint the ice with hues of green, pink, or crimson. These organisms are masters of endurance. They metabolize, reproduce, and form entire ecosystems in conditions where most life would instantly perish. On and around glaciers, life flourishes in other forms. Birds such as plovers, terns, and penguins in the polar regions use glaciers as resting or nesting grounds. Meltwater flowing from glaciers feeds fjords and rivers, carrying nutrients and plankton that sustain fish and marine mammals. Arctic foxes, polar bears, and seals rely on glaciers as vantage points for hunting or shelter from predators and storms. Human beings, too, have long turned to glaciers as archives of the past. Within their layered ice are trapped pollen grains, atmospheric gases, volcanic ash, and ancient microorganisms, an unbroken record of Earth's climate reaching back hundreds of thousands of years. Each layer tells a story of adaptation and survival, a frozen chronicle of the planet's living memory. Though glaciers may appear motionless, the life surrounding them pulses with quiet intensity. Every crevasse, every meltwater pool, every ice surface becomes a meeting ground, a stage for survival and coexistence among organisms large and small. These frozen worlds, harsh and luminous, teach us that life always finds a way, no matter how thin the thread that binds it to existence. Life within glaciers is anything but easy. Temperatures plunge far below zero. Ultraviolet radiation is relentless, and food is scarce. Yet the organisms that survive here have evolved astonishing biochemical adaptations. Psychrophilic bacteria not only endure extreme cold, they thrive in it. Their enzymes remain active at temperatures that would destroy those of most other species, and their cell membranes contain special lipids that prevent their internal fluids from freezing. Some glacier algae create pigments that color snow and ice in striking reds, greens, or pinks. These pigments act as sunscreens, shielding the cells from UV radiation while enabling photosynthesis under dim light. In certain regions, the ice becomes a true oasis of life. Tiny melt pools host microscopic ecosystems of protozoa, crustaceans, and insect larvae. These minute creatures form the base of the food chain, feeding fish, seabirds, and other animals, showing that even in deep cold, life remains intricately connected and surprisingly dynamic. Larger animals display adaptations no less remarkable. Emperor penguins, dwelling near Antarctica's glaciers, endure months of sub-zero darkness and brutal winds, surviving thanks to tightly packed colonies, dense feathers, and thick layers of insulating fat. Polar bears and seals navigate treacherous ice fields with precision, using cracks and thin patches of ice to hunt or rest, while their fur and paws are engineered by evolution to resist freezing temperatures and slippery surfaces. Survival here depends not only on physiology, but on behavioral rhythm. Microorganisms enter dormant states during the long freeze, awakening only when meltwater brings nutrients. Larger animals migrate along glacier edges, following seasonal shifts in prey and using the ice as a bridge to safer breeding grounds. Everything in this world, from bacteria to bears, moves to a rhythm of adaptation, patience, and resilience. Glaciers, though seemingly lifeless, are in truth teeming with vitality, refined by evolution's coldest hand. Every layer of ice, every fissure, every hidden droplet is a capsule of evolutionary history. Proof that life recognizes no boundaries when given the will to endure. Glaciers are far more than colossal masses of ice. They are the planet's regulators of life. From afar they appear static and remote, yet they play a crucial role in shaping climate, rivers, oceans, and entire ecosystems. Each glacier acts as a vast reservoir of fresh water, storing centuries of snowfall and releasing it gradually to sustain distant rivers and lakes. During the melt season, glacial water nourishes vegetation, sustains wildlife, and supplies communities hundreds of kilometers away. Their influence extends beyond land, As glaciers melt, they affect sea levels and ocean temperatures. Cold, dense water, descending from melting ice drives ocean currents and distributes nutrients across vast distances, supporting marine ecosystems from the Arctic to the Antarctic. Fish, plankton, and marine mammals depend on this balance of cold and warmth, a rhythm maintained by the quiet breathing of glaciers. It is no exaggeration to call glaciers the planet's thermostat. Their white surfaces reflect sunlight back into space, preventing Earth from overheating. When ice disappears, darker land and water surfaces absorb more solar energy, accelerating warming, a feedback loop known as the albedo effect, one of the most critical mechanisms driving climate change. Over millennia, glacial erosion has sculpted landscapes, carving valleys, fjords, and alpine basins that later became homes to forests and wildlife. These frozen architects have shaped habitats for alpine plants, mountain birds, and cold-adapted mammals. Glaciers are not just water and rock. They are living systems, a web of energy and interaction that connects every form of life, from microscopic algae to towering predators, through the slow pulse of melting and motion. But in recent decades, the transformation has grown alarming. Rapid melting disrupts rivers, oceans, and weather patterns, threatening millions who depend on glacial water for survival. The loss of freshwater stability, the rise of sea levels, and the shifting of ocean currents are only part of the unfolding crisis. Yet even as they retreat, glaciers remain symbols of nature's endurance and the planet's capacity for balance. Observing them teaches us patience, humility, and the delicate art of coexistence. For life beneath their shadow endures only by following a rhythm measured in millennia. Though glaciers may appear as frozen deserts, they are in fact rich ecosystems, alive with organisms that have mastered survival in extremes. In thin films of meltwater on the surface and within inner cracks, microscopic algae, bacteria, and protozoa form the base of entire food webs. These tiny life forms not only withstand freezing conditions, but also produce pigments that shield them from UV radiation and absorb what little light remains for photosynthesis. They feed minute invertebrates, which in turn nourish fish, birds, and polar mammals. As the climate warms, however, these fragile ecosystems are being torn apart. Microbes and small animals lose their icy homes, while meltwater alters the chemical composition of nearby rivers and lakes. Some species migrate upward or toward colder waters, but many cannot adapt fast enough. Rapid melting also disrupts breeding cycles. Birds lose nesting sites, and aquatic species must endure abrupt changes in temperature and salinity. Among larger animals, polar bears and seals now travel greater distances in search of stable ice, their hunts growing longer and more perilous. Land animals like moose, reindeer, and predatory birds depend on glacial rivers and lakes for food and water, resources now shifting unpredictably. It is not only animals that feel the impact of melting ice. Humans living in Arctic and mountainous regions also experience the consequences of glacial change. Shifting rivers, glacial floods, and rising sea levels force adaptation and relocation, while also transforming traditional ways of life and methods of obtaining food. Yet life in and around glaciers demonstrates an extraordinary capacity for adaptation. Some microorganisms develop resistance to sudden temperature fluctuations, fish adjust their reproductive cycles, and birds and mammals learn to navigate new migratory routes and exploit new food sources. This relentless struggle for survival in extreme environments is proof of nature's resilience and flexibility. Even in the face of dramatic change, looking at glaciers, it is essential to understand that they are not merely frozen mountains. They are living laboratories of evolution, full of mysteries and subtle interactions. Every crevasse, every ice layer, every stream of meltwater is part of a vast network of life, teaching patience, adaptation, and respect for the forces of nature. Melting glaciers not only shape landscapes, but also remind us how delicate life's balance is, and how profoundly climate change affects every level of an ecosystem, from the smallest microorganisms to humans. Glaciers are not just cold, inaccessible masses of ice. They are dynamic, living systems that shape life around them in countless ways. Though few humans venture directly onto their surfaces, nearly every valley, river, and ecosystem at their base feels their presence. For thousands of years, glaciers have provided drinking water, irrigated fields, and sustained ecosystems that could not survive otherwise in harsh high-altitude or Arctic climates. In valleys beneath glaciers, both humans and wildlife benefit directly or indirectly from the wealth that melting ice provides. Glacial water feeds rivers, which in turn nourish plants, fish, mammals, and birds. For human communities in the Himalayas or the Andes, glaciers are indispensable sources of fresh water and energy, and their annual melting sets the rhythm of life and agriculture. Survival near glaciers requires not only physical endurance, but a profound understanding of glacial dynamics. Even seemingly calm ice can change overnight. Cracks, ice avalanches, or glacial floods can threaten both human and animal life. Consequently, local communities have developed adaptive strategies over centuries, enabling them to harness the resources of the glacier while minimizing risk. This chapter examines how glaciers shape life around them, both wild and human. It explores how glacial water fuels valleys, the challenges posed by extreme environments, and how humans have learned to coexist with these icy giants. Understanding glaciers is not only a lesson in survival, but a profound insight into how nature and humanity co-create ecosystems that are simultaneously fragile and resilient. Glaciers are not merely static blocks of ice. Their meltwater forms rivers, lakes, and wetlands that constitute the foundation of life in the valleys below. For wildlife, these waters are a true gift. Fish such as trout and salmon in northern regions rely on cold, oxygen-rich waters for reproduction and feeding. Birds, including migratory species, thrive on the abundance of fish and insects, while mammals from deer to bears visit glacial rivers for water and sustenance. Without glaciers, many of these ecosystems would cease to exist. Rivers would dry in summer, and nutrient-rich sediments would not nourish the valleys. For humans, glaciers are equally vital. In the Himalayas, valley communities live according to the rhythm of glacial melt, which supplies essential water in summer for irrigating rice paddies and grain fields. In the Andes, glacier-fed rivers power hydroelectric systems and drive water mills. Understanding the cycle of melting and water flow is a matter of life and death. Misreading glacial signals can result in catastrophes, such as glacial floods which can destroy bridges, homes, and crops within minutes. Glaciers also influence the microclimate of valleys. Their massive ice reflects sunlight, and melting waters cool the air, creating humid zones that allow plants to grow where they otherwise could not. These regions harbor endemic species, evolved in the shadow of glaciers, and adapted to extreme conditions, from hardy grasses and shrubs to insects and small mammals. Interestingly, glaciers shape valley topography and animal migration routes. Rivers fed by glacial melt dictate paths for deer, mountain goats, and bears, while natural ice barriers and glacial lakes offer safe havens for young animals from predators. Glaciers are therefore not only sources of water, but also architects of entire ecosystems. For humans, life near glaciers demands extraordinary adaptation. Mountain settlements must be located safely away from avalanche zones and floodplains, anticipate seasonal water flows, and store water for periods of slow melting. Local communities have developed traditions and rituals around glaciers. In some cultures, glacier melt signals the start of sowing or harvest seasons, while observations of ice cracks and crevasses help predict floods. In short, glaciers are invisible engineers of valleys, shaping life for both wildlife and humans. Their waters give life, their melting sets the rhythm, and their immense presence teaches that nature functions in subtle interconnections, where every element, from microscopic insects to humans, depends on glacial dynamics. Glaciers are not just majestic ice, mountains quietly traversing continents, and valleys. They are also extraordinary archives of our planet. Each ice layer is like a thin page in a monumental journal, preserving the history of millennia. Snow falling today penetrates the glacier, slowly transforming into ice and trapping air from hundreds or even thousands of years ago. Within these trapped air bubbles lie traces of past atmospheres, concentrations of carbon dioxide, methane, and other gases, enabling scientists to reconstruct climate changes long before humans appeared. Each bubble is a tiny time capsule, and each ice layer reflects seasonal variations, frigid periods, warmer intervals, heavy snowfall, and droughts. But glaciers store more than air. Dust particles, volcanic, mineral, and organic, reach the ice from distant continents, allowing us to trace eruptions, mountain erosion, and even ancient wind currents. Glaciers are like natural chronicles of global events, each grain of dust carrying the story of planetary change. They allow scientists to reconstruct not only climate but ocean dynamics, biosphere shifts, and ice sheet migrations of the past. The most fascinating studies involve ice cores, long cylindrical samples drilled deep into glaciers. Each meter of a core reveals centuries of history. Layers of varying opacity, dust particles, and air bubbles are like reading ancient books, where each line records how the planet responded to natural and human-induced climate changes. Some cores extend back millions of years, providing an extraordinary perspective on Earth's climate evolution and glacial cycles. Glaciers are also unparalleled observers of life. Analysis of pollen, microorganisms, or plant remnants trapped in ice reveals landscapes as they existed thousands of years ago. What grew around ice sheets? How did fauna change? When did new species appear? Every ice layer is a biological note, offering insights into life dynamics in extreme climates. This makes glaciers invaluable to scientists studying the planet's future. Every analysis illuminates mechanisms behind past climate changes and offers clues about what may lie ahead. We see the delicate balance between temperature, precipitation, ice cover, and life, and how every melting fragment of ice uncovers new data while simultaneously erasing irreplaceable history. Standing at the base of a massive glacier, it is impossible not to feel awe. It is not merely a mountain of ice. It is a living book of Earth, a chronicle that has survived millennia, quietly storing the secrets of time. In this silence, in this cold, remote world, every crystal of ice tells a story recorded in chemistry, structure, and air. By looking at a glacier, we glimpse a fragment of the past that can help us understand the present and anticipate the future. Climate change does not leave glaciers untouched. These enormous ice mountains, once silent chronicles, now melt at an unprecedented pace in Earth's geological history. This loss is neither slow nor discreet. Glaciers lose hundreds, sometimes thousands, of cubic meters of ice each year, taking with them a part of recorded history. Every melting layer exposes cracks, fissures, and water channels that carry away microscopic air capsules, dust particles, and organic remnants from thousands of years ago. It is as if the planet is slowly burning its own chronicles. Scientists observing these processes find that rising temperatures and greenhouse gas emissions accelerate, melting and disrupt natural ice accumulation cycles. Glacier dynamics change. Their tongues flow faster toward the sea. New fissures and ice avalanches appear, and ice sheets that were stable for millennia become unstable within decades. Every loss of ice is not only a loss of water. It is the disappearance of unique information about past climates, droughts, glacial periods, and life evolution on continents surrounding ice sheets. What was once difficult to study has now become urgent. Ice core studies, which once allowed the reconstruction of thousands of years of history, are now limited because fewer untouched layers remain. Scientists must act quickly. Each new core is a precious piece of the global chronicle that could vanish before it is fully understood. Meltwater from glaciers not only raises ocean levels, but also changes local ecosystems, affects ocean currents and winds, and consequently impacts weather thousands of kilometers away. Glaciers thus become not only sources of knowledge, but active participants in processes shaping life on Earth. The most dramatic changes occur in the Arctic and Antarctic, where ice sheets reach tens of meters in thickness. The melting of these giants releases vast amounts of water into the oceans, raising sea levels and threatening coastal communities worldwide. At the same time, it exposes new rocks, ancient sediments, and sometimes the remains of prehistoric ecosystems. On one hand, this offers research opportunities. On the other, it is a warning. Human presence and emissions are altering the pace of change so drastically that glaciers that endured millennia now melt within a decade. All this reminds us that glaciers are not just beautiful landscapes. They are fragile archives, responding to every stimulus from the atmosphere, water, and soil. Their melting echoes climate change, testifies to human impact on the planet, and warns future generations. At the edge of a glacier, one sees not only immense ice, but the Earth's past, flowing away in rivers and oceans. Every drop carries a story from thousands of years ago. A story we can never fully recover. A glacier may appear lifeless, a mountain of ice, silence, cold, and emptiness. That is the image we see from the surface. But it is only an illusion. Deep within, between layers of frozen water, exists a world that has endured millions of years in extreme conditions. Scientists have long known that even in seemingly lifeless places, Antarctic and Greenland ice, or Himalayan ice caves, microorganisms not only exist, but actively function. In these microscopic enclaves, bacteria, algae, viruses, and even tiny animals such as tardigrades and rotifers survive. Some can remain dormant for hundreds of thousands of years, awaiting even a slight rise in temperature. When this happens, they wake up, begin breathing, dividing, and processing organic matter. Their survival is proof of life's extraordinary flexibility, able to persist where it seems impossible. One of the most fascinating discoveries in recent years was finding living bacteria in an ice sample over 800,000 years old from Antarctica. Some of these organisms had never encountered the modern Earth's atmosphere. They breathed air from before glacial epochs, before humans set foot on the planet. It is a true microbiological time capsule. Life in ice follows its own rules. Water in such conditions is never completely frozen. Between ice crystals exist microscopic pockets of liquid, containing salts, minerals, and traces of organic matter. It is within these liquid networks in ice that microorganisms move, exchange substances, and survive. This is an extreme environment, dark, poor in oxygen and energy, yet it is home to entire communities of invisible beings. Some of these microorganisms have learned to harness energy in ways entirely different from ours. Instead of sunlight, they exploit chemical energy stored in minerals, and some feed on gases trapped in ice. It is these unique abilities that have led NASA and ESA scientists to study glacial life, not only to understand Earth, but also to prepare for the search for life beyond it. If microbes can survive in the ice of Antarctica, perhaps similar life forms exist beneath the icy crust of Europa, Jupiter's moon, or Enceladus, Saturn's moon. Glaciers thus become not only archives of Earth's history, but also models for extraterrestrial life exploration. As glaciers melt, ancient life is released. Water flowing from retreating ice sheets carries microorganisms trapped for millennia. Some may reproduce again in new environments, while others are entirely alien to contemporary ecosystems. This phenomenon evokes both wonder and fear. No one knows which ancient bacteria or viruses might awaken. In 2016, in northern Siberia, thawing permafrost released anthrax bacteria trapped in a reindeer carcass for over 70 years. It is a reminder that glaciers do not merely store life, they can resurrect it in ways beyond our full control. In ice caves, beneath glacial lakes and in crevasses perpetually frozen, a microscopic drama unfolds: survival, adaptation, and evolution at a slowed pace. For scientists, it is an extraordinary lesson in nature's resilience. Life does not need perfect conditions, warmth, or light, only a spark of energy, a molecule of water, and patience to endure entire epochs. Ice melts, quietly, without thunder, without cinematic spectacle. It is not a disaster in the style of Hollywood, but a slow, drawn-out process that changes our planet year by year, decade by decade. Glaciers, vast ancient water reservoirs that have shaped Earth's surface for millennia, now retreat at a pace never recorded in human history. When ice melts, it does not vanish without trace. Every drop from Greenland, Alaska, or Antarctica reaches the ocean. Though it may seem insignificant, what are a few billion tons of ice against the vast oceans? These changes have profound effects. First, sea levels rise. In the 20th century, they increased by roughly 15 centimeters, but the rate is accelerating dramatically. Satellites now record a rise of 4 millimeters per year, twice the rate of 30 years ago. If trends continue, oceans could rise by a meter by the end of this century. For billions of people living along coasts, this is no abstraction. Entire cities, from Miami to Jakarta, could be partially submerged. Pacific islands like Tuvalu and Kiribati could literally disappear from maps. Climate migrations, already beginning, may become among the largest in human history. Glacial melting is more than just water in the oceans. It also disrupts the great planetary climate engine. Ice plays a key role in Earth's thermal balance, a giant mirror reflecting sunlight back into space. When ice disappears, dark ocean surfaces absorb more heat, accelerating warming. It is a self-reinforcing cycle. More heat melts more ice, and less ice absorbs more heat. Melting also affects ocean circulation. Fresh water from glaciers disrupts density and salinity, influencing currents like the Gulf Stream, which moderates Europe's climate. If this system weakens or stalls, the effects ripple worldwide. Colder winters in Europe, scorching tropics, increasingly unpredictable storms. In this slow process, ice releases not only water but history. Millions of tons of trapped greenhouse gases, such as methane and carbon dioxide, preserved for millennia. As permafrost melts, these gases escape into the atmosphere, intensifying the greenhouse effect. Ice, once guardian of climatic balance, becomes its victim. Yet there is something deeply symbolic in this picture. Glaciers are more than geology. They are the memory of the planet. Their disappearance is not merely the loss of ice, but the loss of silence that endured for ages. For Arctic and Himalayan peoples, ice has spiritual significance. It is life, a spirit of nature not to be underestimated. When it melts, landscapes vanish, along with entire cultures, languages, and traditions. In Antarctica, where unbroken ice once dominated, black rocks and flowing streams now appear. Satellite images show white fields shrinking year by year. The process is almost imperceptible day by day, yet relentless over decades. Some scientists describe our era as the planetary deglaciation. Others call it the end of the age of silence. For when ice falls silent, the ocean begins to speak, and its voice will grow louder. Imagine a world map from a century ago. Familiar coastlines, seemingly eternal. Now imagine that map no longer exists, not because humans destroyed it, but because Earth itself has begun to change, quietly, slowly, millimeter by millimeter. Where land once held firm, water begins to spread. Where ice once gripped everything, new seas and lakes form. This is the birth of a new ocean, a work created not in laboratories, but in the planet itself. As glaciers melt, they do more than raise sea levels. In regions where their weight pressed the crust for millennia, isostatic rebound occurs, slow lifting of continents as the ice vanishes. Paradoxically, while some areas sink beneath water, others rise. In Scandinavia and Alaska, land literally grows, up to a centimeter per year. This is an echo of past ice ages, still resonating in the landscape. In the Arctic, a phenomenon geologists call the 21st century Arctic Ocean is emerging. As summer ice retreats, previously inaccessible sea routes open, the northern sea route along Russia's coast, linking the Atlantic and Pacific. A few decades ago, this was a geographical fantasy. Today, it is an economic and political reality. Ships, once forced to traverse the Suez Canal, now cut thousands of kilometers through lands once dominated by permanent ice. Meanwhile, in Greenland, Siberia, and Canada, water from melting glaciers forms new proglacial lakes, some larger than entire cities. From space, they appear as deep blue patches expanding each year. For scientists, they are real-time laboratories of climate change. New life emerges, bacteria, algae, and microorganisms that previously had no access to light or oxygen. The birth of a new ocean is not just geography. It is a new climatic era. Fresh glacial water mixes with salty oceans, altering salinity and temperature. This affects the thermohaline circulation, the massive system of currents distributing heat globally. If disrupted, we may face a new global order, hotter tropics, colder and stormier northern Europe. In some scenarios, scientists predict that by the end of this century, the Arctic Ocean could be ice-free in summer. This is not merely symbolic. It shifts the energy balance of the entire Earth. The ocean will absorb heat previously reflected by ice, accelerating global warming. A domino effect unfolds. The loss of one balance element triggers a cascade of changes, difficult to stop. The new ocean also brings new boundaries and conflicts. Nations such as Russia, Canada, Norway, and the United States already compete for resources once hidden beneath ice: oil, gas, and rare earth metals. Exploiting them will generate further emissions and warming. A vicious cycle. Yet within this story are glimmers of hope. The new ocean offers opportunities to discover unknown ecosystems. In melting ice, scientists find microorganisms dormant for millions of years. Biological time capsules. Perhaps their DNA holds answers to questions about the origins of life on Earth and even the possibility of life elsewhere. Earth has always been a master of transformation. Glaciers came and went, seas appeared and vanished. The difference now is that change occurs within a human lifetime, not millennia. A time span we can witness with our own eyes. The new ocean is already being born, not with roaring waves, but in quiet melting. And as each drop flows to the sea, Earth writes a new chapter in its story, a chapter we are witnessing ourselves. Standing at a glacier's edge, silence may first seem absolute. Yet if you listen carefully, you hear strange sounds, creaks, cracks, gurgles, and sometimes a low, deep roar. It is neither accident nor whim of nature. It is the language of ice, a story glaciers have been telling for thousands of years. Each sound marks movement, melting, mass shifts, and responses to changing temperature and pressure. Some glaciers sing in what scientists call ice harmony. Depending on temperature, tension, and ice thickness, tones and durations shift almost daily. It is as if enormous invisible organs play their own melody, beyond human comprehension, yet full of information. These sounds can warn of sudden cracks, calving, and melting rates. When ice fractures, it creates a miniature thunder, a powerful crack echoing through the valley. Those fluent in the glacier's language know something has changed in the mass. Some cracks signal imminent icebergs breaking into the sea, a spectacular display of nature's power and fragility. Not only cracking sounds speak of glaciers. Sometimes bubbling and hissing from water-filled crevasses is audible. Water penetrates fissures, increases pressure, and drives slow ice movement. It is like the breath of a giant, invisible, silent, yet charged with energy capable of catastrophic release. Some phenomena appear almost mystical. At night, under a full moon, as cold air chills the surface, glaciers emit a low, pulsing tone, resonating through valleys and reflecting from mountain walls. Locals call it the song of ice spirits, an echo of ancient epochs when glaciers shaped landscapes, carved valleys, and formed mountains. Scientists confirm it is a natural physical process, yet its poetic interpretation connects us to the past and nature's power. These sounds are not random. Each glacier responds to temperature, wind, atmospheric pressure, and water flow. It is a warning system signaling structural changes. In practice, glaciers speak to scientists, alerting them to sudden events like massive calving and ice tsunamis, rare but potentially catastrophic for coasts. The great lesson these ice spirits give is this: nature always communicates, though sometimes its language is too subtle to decode without attention and patience. Listening to a glacier teaches not only the history of climate and Earth's movements, but also something deeper. The sense that the world lives and breathes independently of us, and we are merely witnesses. Imagine a planet where glaciers suddenly cease to exist. The colossal ice masses that for millennia have slowly shaped landscapes, stored fresh water, and regulated climate vanish within decades. This is not a scenario from a disaster movie. It is a vision scientists study as a possible outcome of global warming. The seas would be the first to change. Glaciers, both polar and mountain, hold enormous reserves of fresh water. If they melted, ocean levels would rise by tens of meters. Imagine coastal cities, New York, Tokyo, London, Rio de Janeiro, partially or completely submerged, with hundreds of millions forced to evacuate. The waves we know today would be nothing compared to this gigantic surge of rising water. The climate itself would shift. Glaciers act as giant Earth thermostats, reflecting some solar radiation and cooling the planet. Without them, the planet's surface would heat faster, and regions now temperate would face extreme heat waves. Weather zones would shift, new deserts would emerge, and monsoon patterns would change dramatically, affecting agriculture and access to drinking water. River systems fed by glacial melt would also be severely affected. Millions of people in Asia, Africa, and South America rely on mountain rivers regulated for centuries by glaciers. Without them, summers would bring droughts, while winter precipitation would be insufficient to replenish supplies. Farming would become wildly unpredictable, and scarcity of water could spark conflicts and mass migrations. It is not only humans who would suffer. Ecosystems that developed alongside glaciers would suddenly lose their habitat. The Alps, Himalayas, Andes, and Rockies would be left without ice, and animals dependent on cold streams and snow, from mountain goats to polar bears, would face dramatic habitat loss. Oceans too would feel the change. Melting glaciers would alter ocean currents, water temperature, and salinity, disrupting migrations of fish, plankton, and marine mammals. From space, Earth would appear with drastically reduced whiteness at the poles and gray exposed mountains where glaciers once reigned. Landscapes would undergo complete transformation, happening at a pace unimaginable to the human eye. What today develops over millennia would suddenly have to adapt in decades. Perhaps the most dramatic consequence would be the loss of natural freshwater reservoirs. In tropical, subtropical, and semi-arid regions, pressure on rivers and lakes would increase, forcing humanity to cope with water scarcity in ways that now seem extreme. Building colossal dams, desalinating seawater, or undertaking massive climate migrations. Glaciers are more than icy giants. They are climate guardians, water reservoirs, and landscape sculptors. Their disappearance would not be a local catastrophe, but a global shock, affecting humans, animals, and plants across the planet. It is a warning, a reminder that even the greatest forces of nature, cold, immovable ice mountains, shape every aspect of life on Earth. If glaciers vanished entirely, the consequences for humanity would be immediate and long-lasting. People could no longer rely on natural freshwater reservoirs, which slowly released water during droughts for thousands of years. Mountain rivers, today stable sources of drinking water, would become unpredictable, drying in summer and flooding in winter due to intense rains. Hundreds of millions of people in Central Asia, South America, and Eastern Europe, dependent on melting glaciers in the Himalayas, Andes, or Alps, would be profoundly affected. Agriculture would become dangerously unpredictable. Crops requiring stable soil moisture, rice in Asia, maize in Central America, could suffer severe yield reductions. The lack of reliable water resources would force massive investments in irrigation systems and storage infrastructure, demanding enormous financial and technological effort. Meanwhile, climate changes caused by the absence of glaciers, higher temperatures, more frequent heat waves, and shifts in atmospheric currents would trigger climatic collapse, further complicating life and agriculture. Coastal cities would experience the impact of rising seas, driven largely by glacial melt. Even a modest rise over decades could force millions to relocate. Ports, industrial zones, and residential districts would become unusable, pushing the global economy into an unprecedented infrastructure crisis. Energy systems would also be dramatically affected. Many regions rely on hydropower fed by mountain rivers. With glaciers gone, water flows would become erratic. Winter floods and summer droughts would limit power production. Countries dependent on these sources would have to invest in alternative energy, facing potential instability. Human health would also suffer from freshwater shortages and climate change. Droughts would encourage outbreaks of infectious diseases, limited drinking water would heighten epidemic risks, and extreme heat waves would endanger lives through heat stroke and dehydration. Climate migrations from the most affected areas would spark conflicts over land and water, generating political and social pressure worldwide. Glaciers are not just natural water reservoirs. They are the foundation of life's stability on Earth. Their disappearance would unleash a cascade of dramatic consequences, affecting every aspect of human existence, from access to water and food to energy, health, and migration. It reveals how profoundly our lives are connected to these icy giants, which, though remote and seemingly untouchable, wield immense influence over the fate of all humanity.